Okay, we move now to the next presentation. Sofia Bonicalzi, Associate Professor of Ethics, Università di Roma 3. And we're in the light of neuroscience. So we have left the historical field and now we're moving into the challenges to the idea of will.
Okay, well, thank you so much for having me. Thank you for the invitation, Carlo. And I hope this talk won't be too strange with respect to the other things you are interested in. I'm very grateful because I've learned a lot today. So thanks. So let's start already by saying that neuroscience has addressed the classical philosophical problem of the will, which you have so magnificently described today, through a quite narrow lens. Does the will cause action? That's a central problem for neuroscientists, which is often immediately translated into something that is already more manageable, something like that. Do intentional mental states produce willed behavior? So I will try to mainly address this point, trying to combine philosophical reflection and neuroscience a bit. So, of course, this framing reflects a kind of reduction of a much, much broader philosophical problem. We heard a lot about Nietzsche today. So, of course, it's a very different notion with respect to Nietzsche and to many others you have exposed today. It turns into a causal efficacy question. Can intention and decision causally influence behavioral output? I was impressed by a quotation by Schopenhauer today that you mentioned, where Schopenhauer was saying that we should not interpret, I think it was in your slide, that we should not try to address the problem in a causal way. But that's exactly how neuroscience tackled the problem. And that's probably because that's the only way in which they can see an immediate neural implementation. How do neural states subserving intention? So, of course, neuroscientists accept that we have something like intention, and they try to understand them in their own terms, which are neurological. So how do this translate into action? And the focus is, of course, empirical. So the measurable input-output relationship, rather than bigger metaphysical, but I could say ontological or political questions about the nature of the will, about freedom, about determinism. Of course, the kind of debate in philosophy that most immediately related to this is a debate about free will and determinism. So the whole compatibilist and compatibilist tradition, which you are probably familiar with, that's a kind of debate they look at, but in the end is about explaining intentional action, something that is apparently guided by the mind, but has somehow to be reduced to the brain. So I have to start with a kind of a terminological premise. So in philosophy, we distinguish between different concepts, such as willed, voluntary, intentional actions. Different philosophers may completely have an overlapping understanding of these concepts. Others may distinguish between them. But if we look at neuroscience, there is, again, a sort of narrowing of the perspective where these concepts are usually described in terms of internally generated actions. The one you see here is a paper that compares internally generated action, willed action, to involuntary or non-intentional actions that are externally triggered by some external cue. It might be sensory, maybe auditory, visual, whatever. But that's the main distinction. So internally generated from within, and externally triggered. If we have to look at the kind of philosophical master that we can look at, and I feel a bit ashamed of mentioning ancient philosophers in front of Linda, obviously, but the inspiration is more or less the Aristotelian view of voluntary action and involuntary action in the Nicomachean Ethics, where Aristotle describes voluntary action as actions that are generated from within, like where the principle and cause reside within the subject. And Aristotle compares this to involuntary action, the accusio, where involuntary actions are actions that are generated from without, that are triggered by some external stimulus. That's a kind of inspiration, like philosophical inspiration. This weird terminology, I would say, leads to some very unconventional and odd implication. If we imagine that we are driving a car and we decide to press on the accelerator when we see the traffic light turning green, in ordinary terms and in philosophical terms, this will count as a voluntary action. I'm pressing on the accelerator. This is perfectly a voluntary action. In neuroscience, they would consider this as an externally triggered action because I'm just responding to an external stimulus, which is very, very different from what we ordinarily would think, of course. The distinction between internally generated willed action and externally triggered action holds at a neural level. We can easily distinguish, in particular using fMRI and other methods, between areas of the brain that enable us to perform voluntary, willed, internally generated action and externally triggered ones. So in particular, internally generated action are enabled by central areas, central motor areas, while externally triggered ones are more parietal. So this distinction that is so weird, the one I was mentioning before about the car, this will be implemented at the neural level. So if we look at this kind of action, we would expect an activation on the lateral side of the brain. And already we see that there is something weird, doesn't entirely satisfy us. It's not our ordinary conception of voluntary action. And this is also the source of a lot of misunderstandings across the borders. So how do we know what type, that different types of action are linked with different brain areas? Well, just to give you a very simple example, a toy example, usually in a basic experiment, people perform an action that is kinematically identical, but in one case is internally generated. So the subject can perform it at his own pace whenever she wants, while in the other case is an externally triggered action, like the subject makes exactly the same action, but is responding to some kind of cue. And the idea is that we can compare brain activity for internally generated and externally triggered action. This kind of line of research has a lot of super important applications in the real world. Just to give you an example, brain-computer interfaces are tools, devices that translate neural activity, so capture this neural activity, and they translated it into commands that can be used to control external devices that can be used to allow the people to perform willed action. They can be used for motor action. They can be used even for a more like conceptual, theoretical task, like the person writing hello on the screen without using his hands, but just using some, in this case, is an electrode array placed under his scalp. This has immense potential for neurorecovery, neurorehabilitation for patients with neurological disease, but also the usage of this kind of tools may lead to alteration on the subjectively perceived sense of will and agency. So the way subjects feel about their own action when they use this kind of device to control external stuff, well, it's not the same as performing your own action, of course. So the standard philosophical concern about this kind of literature is that, well, this neuroscientific reduction brackets many classical philosophical concepts, as I said before, free will, moral responsibility, metaphysical determinism, I may add many more. The will is something much bigger than this, in favor of tractable questions about intention to action pathways. So my key question here is, how has the interaction between science and philosophy shaped our understanding of will and agency in the last few decades? And if we have to look at a place in philosophy, in recent philosophy, where there seemed to be a match, a clear match of interests and questions between philosophy and neuroscience, probably the first thing I could think of is Donald Davidson's theory of action, which is very much different from the perspective proposed by Schopenhauer, of course, because Davidson was asking something that looks like a causal efficacy question. So if the question in neuroscience can be framed in terms of can intentions and decisions causally influence behavioral output, Davidson has somehow the same kind of perspective, even though his metaphysical outcome was very, very strange. I will not go into that. He proposes very famously what is called the causal theory of action in a number of papers, starting in 1963 and then many more later. It came in two different versions, at least. In one version, probably the most famous one, Davidson said that basically an action is intentional, is willed, when it is caused in the appropriate way by an agent's desire and an agent belief. So it's a combination of desire and belief. The agent acts intentionally because she wants to do X and believes that doing Y will bring about X. A second version of the more or less same theory gives more, focuses more on the concept of intention. And the version is something like that. An agent A intentionally does B if and only if the fact that A does B is caused by A's intention to do B. Just to give an example, my action of opening the door, but it can be applied to any action, of course, is intentional if I had the desire to open the door and the belief that turning the handle down, I will be able to open the door. So it's a combination of a kind of pro-attitude, conative state, and a belief. So if we look at Davidson, we have to respond in a kind of positive, affirmative way to the question that neuroscience is positing. Yes, intention and decision causally influence behavioral outputs. The problem is that, Davidson and many others, of course, treat conscious intentions as causal drivers of intentional willed behavior. But this perspective has been questioned, let's say, by neuroscience. Contemporary neuroscience has raised significant doubts about this picture, challenging the idea that willed actions are caused by conscious mental states. The obvious starting point for this is an experiment done in the 80s. So in comparison with the neuroscience history, a quite old experiment, probably overly discussed. I don't know if you are familiar with that already. Is the Libet experiment. I don't know if you know it already. You know it already, but you study neuroscience, you said. Okay, so I will very briefly go through it for those of you who don't know it. So first of all, is an EEG experiment. So it's done with electroencephalography. Subjects wear a cap, like the one you see here. The cap is covered with electrodes, usually 64, to cover more or less the whole brain. And what you see here, maybe you have done some EEG in your life for medical purposes. What you see here is a typical chart of an EEG recording. It's a continuous recording. This line here, the horizontal line, is the time. So we see the time that goes on, and each row corresponds to a single electrode. So line 1 might be this electrode, for instance. So typically you have 64 electrodes, 64 channels, and 64 rows. Okay, so Libet was an American neurophysiologist. He died a few years ago. He started working on this topic in the early 80s and really changed the way we discuss about this topic. The task participants had to do was extremely simple. I will just briefly go through it. So participants sit at a table and they have to make very simple movements, which can be something like pressing a button, moving a finger, flexing their wrist, very simple stuff. In the meantime, their brain activity is recorded through an EEG system. EEG, I have to say, is one of the oldest and more reliable techniques in neuroscience. It was invented in the 20s, so it has a very long and established history. And it is used mainly for mental chronometry, so to study when things happen in your brain, because it's extremely precise in terms of timing. It goes to milliseconds. And the reason for that is that it records electrical activity, and you know electricity is very fast, so we can have a sort of real-time impression of what happens in your brain. So basically the subject has to press the button, let's say, and in front of him, of her, there is a sort of clock. They have to check the clock while they're doing the task, and after they press the button, they have to report to the experimenter when the dot, this circling dot, was when they decided to make the movement. So when they developed the conscious intention of wanting to make a movement, not when they press, but when they decided to press. So let's say that they press at 5, they may report that their intention started at 4, something like that. The main areas that were interesting for Libet in the brain were, of course, the motor areas that we were discussing before, so central area of the brain. So electrodes have names that are combinations of letters and number, depending on the specific position they occupy on the scalp. And FCZ is a central, C is central, electrode that is more or less here. This is the area and corresponds to the central area we were discussing before as important for internally generated actions. So these are internally generated actions. These are self-paced. This is a sort of prototype of what an intentional action, although a very, very simple one, of course, but that's the usual problem for neuroscience. They have to simplify things to make them manageable and controllable. So the point is to see what happens in the brain when the subject performs an intentional action, self-paced one. And that's the main result of the Libet experiment. So the subject performed the task in many different trials, let's say 90 trials. Each line in this case, correspond to one trial. And the experimenter basically averaged together all the trials and obtained something like this, which, as you see, is much cleaner than this. And the reason is that when you average together multiple trials, you basically remove the noise and you obtain something that is very clean and clear, if things go well, of course. So what can we see from this? So basically, this is the line of time again, the horizontal axis. The vertical axis is the voltage, so the amplitude of the signal, of the electrical signal. At time 0, here is a time when the subject makes the action. So in this case, press the button or flex the wrist, move the finger, whatever the action is, it doesn't make any difference. So at time 0, the subject acts. At time W, the time of the will, is when the subject realizes that she wants to act. So let's say that the subject moves at time 0, at time -1, the subject perceives that she wants to move. The specific expression, which was a bit weird, that Libet used to describe this moment is that something like when the subject feels the urge to move. Urge is something like a desire, but is a very weird way of expressing. Okay, but it's not surprising, of course, the conscious intention, the will, precedes the action. This is kind of obvious. There is nothing special about this. The problem is that much before the subject perceives that she wants to move, we see this electrical activity in the brain, this rise in the electrical activity of the brain that precedes the time of the action, of course, but precedes even the time of conscious awareness of wanting to make a movement. Libet called this the readiness potential. He was actually not the only one who was working on that. He was using the work of some German neurophysiologists who started this experimental line. He called it the readiness potential, which is traditionally considered a signal of planning and preparation for a volitional, a voluntary movement. The problem is that at this temporal stage, the subject has still no idea that he wants to make a move. He still has no desire to move, at least that he reported to the experimenter. So the conclusion Libet was drawing about this was that basically before we develop a conscious will of wanting to do something, our brain has already decided for us. So basically free will does not exist. Well, curiously, Libet himself was a defensor of free will, but he had a very, very weird theory of what free will was. And I will not go into that because it's very strange. But he says, of course, free will cannot be something like the initiation of a voluntary movement, because with this kind of experiment, I have proven that our brain decides before us. This is a short quote from Libet. He says, free will cannot be viewed as an initiator of such a freely voluntary process. We clearly found that the initiation of the preparation to culminate in a freely voluntary movement arises unconsciously in the brain, preceding the conscious awareness of wanting or intending to act now by about 400 milliseconds or more. This result is very stable, so it has been done many, many times, and the kind of pattern we see is more or less always the same, with variation across experiment, but that's the main idea. So some people, not Libet actually, because as I said, he defended somehow free will in other works. But many people reading this result and the old tradition that started from Libet concluded, and this is a philosophical view, is not a neuroscientific view, and accept a sort of epiphenomenal or epiphenomenist view of the will, according to which mental states or events are caused by physical brain processes that happen before at a subpersonal level and of which we are not conscious. But these mental states of events have no causal influence on physical events or behavior themselves. So mental phenomena, things like desires, beliefs, intention, arise as byproducts, so epiphenomena, without downward causation. The most famous defender of this view is probably Daniel Wagner. He is himself a neuroscientist, mostly a psychologist actually, and his most famous book is The Illusion of Conscious Will, that was published in the early 2000s. And basically in this book, he defends the idea that we have this illusion, the will as a driving force of behavior, but this is actually an illusion. It goes against a lot of ideas in philosophy from Davidson, so the causal theory of action, the idea that mental states are causally efficacious and they produce behavior, but also other philosophers we can quote, for instance, William James, having the idea of willpower as a sort of an intuitive explanation of human behavior. So how Wagner defends this epiphenomenism? Basically, his suggestion is that, yes, of course, we have this kind of immediate experience of conscious will. We have that. I raise my hand because I want to raise my hand. I have this force within myself, this will that causes me to act. So I explain behavior based on an act of conscious will. That's our typical explanation that corresponds to our experience, everyday experience, subjective experience. But what is conscious will? So Wagner says something like this. So, of course, we experience this sensation. We have a sensation when performing an action. We perform the action, and we have the experience of being the cause of that action throughout an act of our will. But this should not be mistaken for a real force of the mind, for a true causal link between mind and action. So will that is just an experience is mistakenly turned into the real cause, the real mechanism that drives mental states and action in this case. The problem is that we should not trust our experience as veridical, as truthful. And the reason for this distrust, according to Wagner, is based on many things, including everyday experiences where our experience, our subjective experience, doesn't match the real cause of action, including episodes of automatism, but also pathologies. The most famous one is the anarchic hand syndrome. You've probably seen Dr. Strangelove, who had this strange pathology. I mean, of course, it's a caricature, it's a bit exaggerated, but neuroscientists study a lot people with anarchic hand syndrome. And they describe them as people who perform action that seem voluntary, that are enabled by the kind of brain circuits that enable normal, internally generated voluntary action in healthy subjects, but that they are felt as uncontrolled, as unwilled. So the two things, the real causal pathway and the experience, can be really or ought to be disentangled, according to Wagner. Wagner himself actually ran a lot of experiments on what he calls illusions of control. These are experiments where we see subjects that illude themselves about being the cause of an action, while actually the action was caused by someone else or an external source, and subjects are not aware of that, and they are very easily tricked into believing that they are the author of the action. An interesting experiment in this sense about illusion of control was done by Desmourget and colleague in 2009. Basically, this is an experiment where brain activity is not just recorded as with EEG techniques, but change is manipulated through electrical stimulation of the brain, externally driven electrical stimulation of the brain. And what we see from this kind of experiment is that if we stimulate specific part of the brain, we can really create the illusion of acting in a voluntary way. For instance, a stimulation of the lower right parietal region produces the intention to move the limbs on the left side of the body. Stimulation of the lower left parietal regions produces the intention to move the mouth or even to speak. And when the intensity of the stimulation increases enough, patients or subjects in general believe that they have actually performed the movement, although we didn't see any electromyographic activity, so any muscle activity, nothing really happened, but the participants had the subjective experience of acting in a willed way. Stimulation of the premotor region caused the mouth to open and the limbs on the opposite side of the body to move, but participants deny having moved. So it's really easy to trick people in this sense. These findings altogether suggest to people like Wagner, not to everyone, that the conscious experience of willing to act may be constructed by specific parietal and premotor systems that have nothing to do with the systems in the brain that enable action in a kind of more mechanistic way. So this experience is constructed by other parts of the brain, does not reflect the initiation of a real movement, of a real action, even of speech, because as we see, participants even start speaking without having the impression of speaking or the other way around. This supports the idea for some that conscious will, at least partially, is illusory. Of course, at least partially, because we know the will might be other things as well. It might be wrong to reduce it to this. But at least if we have this kind of understanding of the will, it may seem that this is kind of illusory. Okay, so the point for Wagner and others, so I just take Wagner because he's very exemplary in this sense, but there are many other people who think the same. So basically the idea is that, as Hume already suggested, causality is not a property of objects, but an event or a relation that we can just infer from the outside. We see the red dot moving and then the green dot moving. We infer that the moving of the red dot causes the moving of the green dot, but it is just an inference that we draw. There is nothing that really is make causality a property of object. And according to Wagner and others, the same applies to our mind. Defining will as a force, as a driving force within consciousness goes really beyond what we can observe. It is just a causal inference. It might be right or wrong, but it's an inference. Wagner defines this as the mind's best trick, a confusion between the real causal mechanism and the experience of will. And based on this, many have subscribed to the theory of apparent mental causation, according to which we experience conscious will in cases when we interpret our thoughts as the cause of the action. And this explains why we feel causal agents. And in general, the tendency to attribute mental states, to attribute willed action has been shown by psychologists and neuroscientists to be really ubiquitous. I really love this classic experiment done by Heider and Zimmel in the 40s. In this experiment, they were already able to create like small vignettes, like moving vignette sequences like this. It's extremely simple. You see like a dot and triangles. They are moving. They have no faces. Of course, they have no real intention. This is just a cartoon. But participants, when we see these kind of things, immediately have the tendency to attribute mental states, to attribute will, even to this like basic like structure, shapes. I'm turning to the point of shapes. These are real shapes. So if you see the cartoon and pay some attention to it, you will probably start thinking, oh, the poor circle is trying to hide in this kind of little house. And then there is this very aggressive Brian Leiter type of person who is trying to attack him, and the other one is defending the poor circle or something like that. Okay, so we perceive people and even objects as causal agents acting towards goals. That's our tendency, but it's a kind of projection, according to people like Wagner. It fits well with other theories in philosophy of mind, for instance, Dennett's intentional stance, according to which we have the tendency to overinterpret minds in terms of beliefs, desires, and rational action. How much time do we? Okay, no. Okay, so basically we do not know the real causes of our action, and conscious will is a fantastic simplification of complex mechanisms that we cannot understand. This is a bit similar to what Spinoza was saying about, the famous story of the Spinoza stone. There is a stone that is in motion, and at some point he becomes conscious and starts thinking that he is the cause of his own motion, but actually is unaware of the fact that a human throws itself into the river or whatever. So basically we are like the Spinozian stone. Wagner, if we have to find a sort of philosophical counterpart of Wagner-Dennett line of reasoning, we can probably mention Wittgenstein. Wittgenstein very famously suggested that, or argued that, we have to separate between reasons and causes. These are two different things. He made this very famous example. He says, I read the quote, suppose a train driver sees a flashing red signal and stops the train. And when we ask, well, why did you stop the train? He might reply, well, because the signal said stop. And this is often mistaken for a statement of cause when it is really a statement of a reason. The actual cause may be his long-standing habit of responding to red signal in a certain way, or stable neural pathways in his nervous system, such that the action follows the simulation almost like a reflex or something else entirely. Causes are something that we cannot penetrate. It's a different realm. It's not the realm that we can penetrate with thoughts. The cause may be even unknown to him. The driver may have no idea why he stops the train. The reason, by contrast, is what he reports. As Elizabeth Anscombe, a Wittgensteinian scholar, says, we might be unaware of causes. We are never unaware of reason, because reason is something that we created. So we fabricate reason to give our mental life a kind of unity. So when do we have the feeling of conscious will? Why sometimes I have it and sometimes I don't? We still need an explanation for this, given that conscious will is illusory. And people like Wagner have an explanation for this. They suggest that when some key elements are present, and they suggest that the key elements are priority, consistency, and exclusivity, then we develop this illusion. Priority means that our thoughts happen before the action. Consistency, that our thoughts are consistent with the action, they match in terms of content. And exclusivity in terms of the fact that we don't see other possible causes that might have caused the movement on behalf of us. Well, in these cases, conscious thoughts are perceived as the cause of the action. But Wagner's idea is that conscious thoughts are like the magnetic pointer of a compass. It does not steer the ship, it is just an epiphenomenon. So basically, conscious will, and will in general, is the result of an interpretive system useful for organizing our understanding of agency, distinguishing ourselves from others, experiencing ourselves as morally responsible for action, but real causes are really unconscious, they remain unconscious. So, of course, this literature has generated a lot of replies, a flood of criticism, so that we can just spend hours discussing about the weaknesses of these approaches. But I will say that it is really a crossroad for understanding the troubled relationship between philosophy and neuroscience on the topic of the will. And if I still have some time, I might explore some of these criticism, perhaps, and some of these problems. So a sort of overarching question I ask myself is whether the Libet tradition, and I include Wagner and many others, let's just stick to Libet for simplicity, but everyone is included here, whether this tradition has meaningfully advanced our understanding of will and agency, whether it has fostered productive dialogue between philosophy and science, whether it has contributed to conceptual progress, for instance, about the notion of the will, or whether it has hindered this kind of conversation by promoting an oversimplified interpretation of what will is or what agency is. This is the basic criticism. It's too simple to simplify it. Conversely, we may even ask the other question, does philosophy contribute to science? Does it give any fruitful contribution? We heard a lot today from Anthony about very interesting possible interaction between philosophical ideas and the science. So a question could be, well, how the philosophical criticism to this kind of literature that have been a lot of them, do they have help neuroscientists, or they've been just like not promoting any kind of progress? They have like indulged in a kind of excess of unproductive criticism. So that these are the kind of questions I can explore a bit in the last 10 minutes. I don't think there is a unified answer, of course, as always in philosophy, but here are some proposals. So the first answer I will give is that, well, there are, I think, some philosophical criticism that have successfully prompted scientists to refine this experimental tradition, or even to propose radically new interpretation of the data. So at least in that respect, there has been a productive dialogue. I'll give you some examples. So one very classic objection to the Libet experiment is that the experiment basically shows that we are very bad in terms of introspecting, in terms of understanding when we were aware, wanting to make a movement. We are basically not fully aware of when we decide to act. We are just imprecise. It's not that we don't have free will or we don't have the will that is cause action. We are just not very precise. So the claim of those people who make this objection is that, well, inaccuracies in conscious reporting ought not to be taken as enough to reject the role of the will. This is a very popular criticism. Well, I think I don't believe entirely this criticism for this reason. Well, first, the experiment has been repeated with very consistent result. If it was just a matter of random inaccuracies, well, this would produce at least more variation. If anything, this stability of the mistake, let's say, may point to a bias, a sort of average delay in attention being directed to the already formed intention rather than mere error. I think this explanation is too simple. Inaccuracies are irregular, biases are systematic. But although this criticism, I think, is not entirely correct, it has prompted a lot of experimental development, which are in themselves very interesting. For instance, the Libet experiment, or the kind of things he wants to tackle with his experiment, have been repeated multiple times after Libet with different techniques ranging from functional magnetic resonance to implanted electrodes. This is an array of electrodes that can be implanted directly into the scalp of participants. And there is a quite famous experiment done in 2011, if I'm not wrong, by Isaac Fried, who is a neurophysician, neurosurgeon. And during neurosurgery, he implanted directly the electrode inside the participant's scalp. Of course, it's very invasive, so it can be done only with patients. And thanks to these other techniques, the precursors, the neural precursors of action about which we are unconscious, have been detected up to 10 seconds before the decision to move, making it a bit less likely that the effect is simply due to inaccuracies, because it's a long delay, of course. Okay, theoretically speaking, I have to mention that this line of research is plagued with like a major problem. Usually in EEG experiments, so experiments using electrophysiology, what people do, what experimenters do, is to have some kind of sensory cue that is provided to the participant at time zero. And what they are interested in is to see what happens to the brain after this time zero. So for instance, at time zero, I see a picture, and I want to see then how the brain of the participants respond to the picture seen at time zero in the seconds or milliseconds that, after this time. The problem with the Libet line of research, with the readiness potential in general, is that we don't have a clear onset, because we are interested not in what happens at a specific time that we can point at, so the time of the action, but we are interested in what happens before. So there is no fixed time to start this before. How far back in time we have to look to locate the origin of the readiness potential. So there is no clear answer regarding the question of when does this increase in the electrical activity, when do this precursor happen. And this is a general problem, because with EEG, we have this kind of result. With fMRI, we have to look back, 10 seconds before, but there is nothing like this very simple and neat understanding of what is going on. Another example, the readiness potential, this is another typical objection. Well, it appears only after averaging across trials, not at single instances of behavior. So as this is the picture I've shown you before, these are multiple trials. Each line you see here is one line. And if we one trial, and if we isolate one trial, typically we don't see the readiness potential. So if that's the case, these seem to undermine the idea that the readiness potential plays a causal role in generating action. Because if it is really the cause of the action, I would expect to see it in every single instance of behavior. And that's not what Libet sees. If we don't, the participants had to repeat the experiment at the trial like 90 times. Otherwise, we will not see it if we average together like 10 trials. So that's a big problem, because the causal linkage between the readiness potential is basically what, the main claim of this whole tradition. This has brought to some experimental developments. So with this philosophical criticism, this came from philosophers as well. And with new experimental methods using, for instance, brain-computer interfaces, which can interact with the brain of the participant in a kind of real-time way, scientists recently, and here the key name is John Dylan Haynes, who is a neuroscientist working in Berlin. This is an experiment by his group where the person who did the experiment was Schulze Kraft, who was a postdoc in his lab at the time. they were able to detect the readiness potential at the level of the single trials, combining EEG, so classic electrophysiology with brain-computer interfaces, also providing a clear picture of the readiness potential and the shape of the readiness potential in single subject and how it differs across subjects. But it has also led to some theoretical development. So there are some scientists who really are against the majority, let's say. And here the key name is Aaron Schurger. Aaron Schurger is an American scientist. He was based for many years in France. Now he went back to the US and basically gave a sort of new reading of the whole Libet tradition and suggests that Libet might be completely wrong, and that the classic shape of the readiness potential that we see, the one that comes from averaging together multiple trials, might actually be due to some statistical error in the way it was treating the material, which has nothing to do with the idea that Libet had of a kind of deterministic build-up of electrical activity, which necessarily at some point make the action to occur. Actually, Schurger has a much more indeterministic model of how action occurs. He suggests that electrical activity in the brain goes up and down, and at some point it reaches a threshold in a kind of indeterministic way, and when the threshold is reached, then the action occurs. So it doesn't say free will, although some people will suggest that it does, but I don't think it's a promising way of satisfying the free will requirement, because it is a kind of random model of how action occurs. Action occurs at random times when the electrical activity in the brain reaches a certain threshold, but we don't have a clear control over that. So it's a very weird move if you want to say free will. Still have 5 minutes? Yeah, okay. Okay, I have my clock, so. Okay, other philosophical criticism, conversely, I think they are a bit misguided or maybe more difficult to translate into concrete experimental progress, something that may be helpful for scientists. An example, there are people saying in philosophy, well, the experiment is not really about free action, willed action, because the only really willed action in this experiment is the fact that the participants has decided to participate in the experiment. Once he is sitting down, is at the table, he just has to repeat the action that the experiment told him or her to do, and this is not a free action, it's an imposed action. So actions in this experimental tradition are not genuinely free, but they are predetermined. Well, first of all, they're not predetermined in the sense that they are externally triggered, because participants are told to act at their own pace, whenever they want, not to follow specific patterns. There is no cue that guide their action, so at least they are internally generated. There is a kind of similar objection, which sounds something like this. Well, actions in the experiment, in all these experiments, are repeated multiple times. So they are not genuinely freely willed, but they are just habitual action. And of course, habitual action are something different. Again, this objection doesn't work very well, because habitual action in the brain are enabled by very different neural circuits, which are not the ones that we see in the Libet tradition. But let's start from the first version of this. I think these objections, which is understandable, of course, but seems to overlook the fact that all freely willed action that we perform in real life occur within broader causal chain. They don't come out of the blue. In the Libet type of task, certain variables are constrained, what to do, for instance, but the thing that participants are able to set freely is the time of the action, when to do it. And over that, they retain full freedom, making this action particularly appropriate for mental chronometry studies, because EEG is suited for this kind of studies. So mental chronometry, we want to study when. Just to give an example, if I go shopping, the specific action, the what to do, is already predetermined, of course, but I will still count this as a voluntary free action. I can decide when to do it. I can decide probably whether to do it or today or not. I'm free to decide all these things. I will still call it a free action. But this kind of criticism has led some scientists, and here I will quote Patrick Haggard as the main one, to propose complex multi-level models of intentional action, where intentional action might be intentional willed in terms of the what what to do, the when to do it, or whether to do it or not. And these different aspects, so this is sort of fragmentation of what a voluntary action is. And these different aspects of the action are themselves governed by different neural pathways. The second objection, so the related but second actions are repeated multiple times, so they are just habitual. Well, as I said before, habitual action differ from conscious one, from intentional one. They involve minimal conscious effort. They stem from fixed behavioral patterns. They can come from dispositions rather than specific mental state. But really, in the end, they rely on distinct neural and computational mechanisms that are not the one that we typically see in this experimental tradition. So I think action in the Libet experiment are, of course, simple enough to be the kind of action that in certain circumstances we can perform in an habitual fashion, but this does not mean that the action participants perform in this experiment are habitual, in particular because subjects are explicitly told to pay attention to their intention. And unless we assume that they are unable to do so, we have to assume that these are a kind of action where they are paying attention to their intention. There was a sort of fMRI rendition of the Libet experiment done in the early 2000s by Lau and colleague, another great scientist in this tradition. This was done with the fMRI, and participants were explicitly told to pay attention to their intention in some of the trials, while in some others, they were not instructed in this way. And what we were able to observe is that when participants paid attention to their intention, they were explicitly told to do so, as it happens in the Libet experiment, we see specific activity in the areas of the brain that have been independently associated with intention formation and maintenance in other experiments. Sorry, I think it's very late. I will just make the very last point. Can I make the last point? Okay, or no? No, I stop here otherwise. Okay, so yeah. Okay, no, I won't. Okay, I'll stop here. Okay, I'm done there. Okay. No. Strong, but right. Okay.
Right, so time for questions. I'm quite sure. Many also curiosities, I mean, clarification requests because Paolo was the first to raise his hand. As usual, yes. You know,
Thanks, Sofia. A very interesting and compelling talk. It's been like more than 10 years that I've been working on this, so maybe my questions are really silly. Can you go back to the Libet's experience?
Here, your question, but I cannot share the screen.
Not sure they are interested.
Oh.
No, the next slide. Can you make it bigger? Okay, so my question basically is, can the difference between, readiness, potential, and awareness of intention, can this difference be explained by the delay or by the time that a decision takes to be conscious? Do you see what I mean? Does it make sense? Okay. The other question would be, why do actions need to be conscious in order to be intentional? And what about long-term decision? My problem with Libet's experience is that it's a short-term decision or action. What about, well, I decide to commit suicide? This could be a conscious and intentional decision. Huh? No, sure. But I mean, suppose that I've been thinking about, yeah.
Okay. Okay. No, these are very good questions. So the first one, which is about the difference between the readiness potential onset and the time when we become aware of wanting to make an action. And you were saying, well, perhaps it takes some time. If I understood correctly, it might take some time for the decision to become conscious. Well, I will give two answers, one more empirical, one more theoretical. The first, the theoretical one will be, so you made a decision, but this decision is not conscious yet. Is it a decision if it's not conscious? So what is an unconscious decision? Is something that your brain made. So if that's the case, well, then Libet will agree with you, but say, well, it's not a decision in the sense that you are the person who made the decision. It's something that your brain does. Okay. You are not?
You're not one, it's your brain.
Yeah. Not in the sense that, I mean, Libet himself was a kind of dualist, so it is problematic, but all the others are not dualists. And when they say your brain, of course, I don't think that there is also a mind. I think that the brain does everything. And that at some point, of course, you develop some kind of conscious thoughts, but this has no causal role to play in the subsequent behavior. I don't want to say that they are right. Of course, I'm just presenting this experimental line. So the more like empirical response will be that with the other experiments of the Libet tradition, they were able to anticipate this timing of the, the beginning of the neural precursors up to 10 seconds before. It would be a bit strange to say that it takes 10 seconds to become aware of your own decision. So in that case, I would think that that's not the right way to go. Well, why do action need to be conscious in order to be intentional? It depends on what we mean by conscious. If we think that we have to pay conscious attention to the fact that we are operating voluntarily for the action to be willed, intentional, I would agree with you. Of course, we make many voluntary action without paying attention to the fact that we intended to do them, and they remain voluntary and intentional. But in this specific case, participants were explicitly required to pay attention to their intention. And I would say that in ordinary cases, of course, you make many voluntary action and maybe you are distracted, you don't pay attention to them. But at least in principle, you will be able to pay attention to your intention if you want to do so. In this case, they were instructed to do that. And despite that, we see this kind of pattern. So again, I would disagree that this is the kind of situation in which you are. I think your last point is very, very important. What about long-term decisions? And that's the main problem with this kind of experiment. I think I didn't have the time to cover that. But of course, these are not the kind of decisions that we philosophers typically think of when we consider the topic of will and free will, etc. First, because they are stupid decisions. So there are no, you're just pressing buttons, right? Yeah, these ones. No. These ones, no. Yours are serious ones, of course. No. The decision that participants make in the, no, of course, I'm not saying this. In the Libet experiment are very stupid, so they are not associated with any kind of preference. There is no consequence, so independently of what you do, the solution is exactly the same. This was my last point, so it gives me the opportunity to go there, actually. So what scientists have tried to do in the last few years, exactly because they took this kind of objection seriously. So the objection is something like this: well, actions in the Libet experiment are a bit like the Buridan-Us story. So you choose between identical options. They have no meaning for you, so why? And they are very short-term, all these kind of things. So Libet himself tried to do an experiment where he tried to understand long-term decision, but his long-term decision are like 1 minute or something like that. So of course, it's not very satisfying. I think these remain a big problem. Again, to answer, there have been some studies done with fMRI where they tackle not really long-term decision, but mental action. So I make a decision now, or I make a calculation, or I do something which does not involve a bodily action. Okay, yeah. And what we see is that even in this case of, in the case of mental action, we see again neural precursors, of course, in different areas of the brain, but the pattern is quite similar. The interesting thing regarding the kind of Libet experiment is that in the very last few years, exactly because scientists were told many times these actions are irrelevant, they have nothing to do with real life choices, etc., like the decision for suicide, or maybe not that, but so they tried to combine the field of the neuroscience of action, which is more or less the field in which we will situate Libet, with the field of decision making in cognitive science and neuroscience, which is, of course, much more interested in meaningful decision. And they try to invent like experimental paradigms where participants are embedded in the Libet task, but they make decisions that are similar to the kind of decisions they make in decision-making paradigms. So for instance, there is a study where participants have to press buttons, but depending on the button they press, a certain sum of money will go to a charity that they endorse or they dislike. So they have to decide which charity they want to donate, or they have to make a bit more meaningful decision. And I think this is one of the most interesting line of development. There are no conclusive results. So some of these studies said, well, it's exactly the same. Some others say, no, we see some differences. It's a bit unclear at the moment, but yeah.
Yes, but like this, I think if we go back to the Libet, scheme, I think we have a name for all what is happening from here to there, which is what we call inspiration. For example, when you are, if you do art, it's pretty clear that there is a point in which you know what you do and you are conscious and you do it, but you don't know from where does this come from, but it's evidently already working in yourself in an unconscious way. So that's even when you write. Even when you write a paper, you have something working in yourself, and they say you are set up. Somehow you are in a mental condition, but you don't have an idea. You are not taking any decision, but if you could, let's say, represent that kind of stuff, it will be very similar. I would like to know if there are. I had a friend when I was in Chicago, which was working on this thing in the neurobiology department, and she was obsessed with the haha moment, as they call it. So, what does it mean when an idea comes to you? Is it there before? What is your brain doing before? But even if you like math and you remember at school, there is an aha moment, which is though the W one. So when you know what to do, but of course you are, let's say, mentally active before, but you don't have a decision, you couldn't describe the content of what you have in mind. And I think in the artistic practice, it's pretty much the same. Even if you are composing music, you cannot, or if you paint, you're there, you have your brush, your mind is active, but you don't know what to do. You couldn't describe it. You are not taking a decision, but it's evidently already there. Then if we take this philosophically, there are great pages by Agamben in one of the last book by him, La Faute. There are two essays on topics like this. One is called The Lost Time, which is exactly that kind of time. There is a lost time before and included in your decision. The other one is about inspiration. But it would be nice to think, could it be that our thinking activity is taking part to something impersonal, which is what we call thought? And it's not me thinking, but it's like, thought in the sense of Spinoza, meaning that before let's say by having me think, or is metaxis of course. I mean, that, let's say, thought is in us, and we have a relation to thought before, and the me thinking is somehow, let's say, determination of all of this, but this is already active as an attribute, would Spinoza say. That would be nice to try to see these kind of things with, let's say, kind of putting on the table this kind of, let's say, conceptual classic instruments. And I would like to know if someone is working with these in the neurobiological sense concretely.
Great ideas. I really like this idea of being in a kind of mode of preparing the action. Probably Libet would not completely disagree, because he says, well, for me, the readiness potential is exactly this. It's the fact that your brain is planning, is preparing, is in this kind of state for, at some point, there will be this kind of a haha moment. But the problem is that it's kind of subpersonal. It's not something that you really perceive you're doing. And I think the main problem is that the pattern is really fixed. So there is a fixed amount of time between when this is seen, at least in the EEG experiment Libet done, and the aha moment, which seem very at odds, I think, with our experience, where we will not say, okay, there is this fixed amount of time between when I start thinking about the possibility of doing an action, and which made me think that is probably a bit more mechanistic than this, although I find the idea fascinating. But I mean, it somehow is related, of course. We are preparing some kind of movement that at some point will happen. One thing that I should probably add is that we see the readiness potential only for action that are self-paced, internally generated, and are not responding to external stimuli. So for instance, the example I gave before about the traffic light turning green and you press on the accelerator. If you are at the traffic light waiting for the traffic light to become green and then press on the accelerator, I would say you are in this kind of preparation, ready to press, etc., but you don't see the readiness potential there. If you're just responding to a cue, although you might still be in the state where you know that at some point the traffic light will turn green, so at some point you will have to press on the accelerator. At the moment you press, we don't see this. We don't see this kind of build up. We don't see this pattern. So it's very specific of internally generated action. Actually, Libet was obsessed about this, kept saying to his participant, don't think about what we are doing, just do it. It must come from the inside. He was really attached to this idea of liberty of indifference, if you want, which is really not what we would call free will in the philosophically dense sense. So, of course, there are a lot of problems. At the same time, I think we have to work with what we have. So if we want to somehow connect philosophical concepts and scientific concepts, that's what we have. We can try to improve it, suggest possible refinements conceptually or experimentally. And I think it's a very interesting kind of interaction. But I just don't like the attitude. I mean, I disagree with the attitude of those who are just very dismissive and say, okay, that's nothing, it's irrelevant. It doesn't say anything about the will because we have this big philosophical concept that cannot be, I think this attitude is not very productive in terms of dialogue. But while what you are suggesting is very interesting, so working with the concept, and if you can send me some references, the ones you've mentioned, I would be grateful. Yeah.
Anthony.
Thank you very, very much for that. That was brilliant. I was so happy to see the scientific and neuroscience evidence you presented. I thought that was fantastic. I was familiar with these, but to see you codify everything was great. I love the fact that you brought in Wagner. I mean, that is fantastic. I think he's brilliant. And I think he's brilliant because he confirms a lot of the things that, as I read Nietzsche and Schopenhauer, that denial of the free will, that denial of conscious deliberation that can of itself effectuate action. I see that in Nietzsche all over. He has all sorts of sayings like that where it seems like we have an emotional response, we have a desire, but the recognition of the desire is itself an experience, but it doesn't have a causal relationship with an action. So I love that. I think Nietzsche was right about that. I think Wagner is right about that. What I wanted to push a bit was, it seems like neuroscience makes the distinction between voluntary and involuntary. I think that distinction is a little bit arbitrary with respect to what triggers you or what doesn't trigger you. And you mentioned a little bit, it seems vague what's triggering you. But there's any number of actions that you yourself are doing right now, you're not conscious of. They're definitely intentional, but there's a strange disconnect. So when you are talking, one of the things that, as an American, I notice that all Italian people do is, of course, you talk with your hands, right? And there is this very complicated system of communication there that doesn't seem like much. You probably don't think about it whatsoever. Even if not the hands, your ability to speak, where you're pushing air through a hole in your neck, up through, over your tongue, through the lips, your jaw, your lips, your tongue has to do all of these things to make a word. It's incredibly difficult to do that. And you can say 100 words in a minute. How to do that is something that you probably couldn't even begin to try to describe how to form a word like that. But you do it. It is you. It is, in a sense, not coerced. These are words coming out of your own mind. And yet there is no recognition for exactly how to do it. So it's one of these things that's a little bit the flip of what Paolo was asking, namely a long decision. There is no thinking with this, but you can create unbelievable number of actions like that. That's one. The second point I wanted to make was just a little bit of support, and this is from Schopenhauer, who has similar experiments, but he doesn't have neurological technology to do these experiments, but he asks this question, and I love this one. He says, when and where do you feel pain? And then when and where do you report the pain? Right? So let's say you get hit in the knee or something like this. It isn't the exact moment that you get hit in the knee that you report pain in your knee. It can be quite a long ways off. And you say, where is the pain? He says, it's right here. It's not. It's here. You're a neuroscientist, right? And you could cut off your leg and still feel knee pain, but if you cut off your head, you would feel no pain. So it's obviously in the brain. Schopenhauer's answer for why this happens is not because there's another sort of faculty in the brain that's producing it. His answer is that actions of will are neither spatial nor temporal. So this shows that temporally, there's sort of this disconnect between when I am conscious of a desire to do something or a will to do something and what actually is being activated, but it's also spatial. You could ask any of these people, where is it that your desire to push that button was? And they wouldn't tell you right here. They wouldn't have any idea where it is. So it's interesting that Schopenhauer was trying to explain why that occurs. If you say that you are hungry, when do you begin to become hungry? I don't think anybody can identify that. You can say, well, roughly, 2 o'clock or something. But this is not within 400 milliseconds of the actual experience of being hungry. If you say, when are you full? Well, it's after I ate the pasta or something, but it's not within 500 milliseconds. It's very vague. And where do you feel full? Right here. No, you feel full here, don't you? And so again, space and time for Schopenhauer are these merely subjective forms of cognition, and that's very much disconnected from what the willing is doing. So rather than having another modality of brain that explains why there's the disconnect, what Schopenhauer is saying is the will just isn't in the brain at all. Is not in the brain. The will is not in the brain. So thank you for that.
Great point. Thanks. I don't have much to respond actually to this. With respect to the last point, I would start with that. So many have suggested that the entire way of looking at when the desire starts, when you get the urge to do something, that's an entirely misguided way of looking at the problem, because consciousness is not a point in time or space. This is a continuum. And of course, these things they grow slowly, so you cannot point at a specific time. So of course, I think this is a legitimate criticism, and I don't have a clear answer to this. I think this tradition is interesting. It provides some insights, but it doesn't have an answer to all these problems that you are raising. My take on this is let's try to use these insights for what they are, and they might be useful to solve some problems, but it's very difficult to expect that one single experiment may solve all the problems. What I try to do is put together multiple experiments as I try to do, and they might illuminate a little bit of the story, but we don't have the full picture. Of course, we are also very passive with respect to our desire. As you said, we start being angry. It's not something that we decide to do. It's something that starts in us very slowly. You might be You might decide at some point, okay, I will get an ice cream, and then you know exactly when you decide to do so, but you don't know exactly when you started to want to eat something, so for sure. With respect to the other question, which goes back a bit to what Paolo was saying, so scientists divide between internally generated and externally triggered, but what they want to suggest actually is that it is a continuum, it's not a sharp distinction. And even at the brain level, we see a gradient from central to parietal areas, depending on how externally triggered the action is. If we are totally passive, using Aristotle's way of saying, then you see really a localization in this part. If it is really something that comes from within you and you don't have any external cue, then it's localized here. But it's a gradient, it's not yes or no. Of course, we do a lot of actions that are still, I would still call them voluntary, if not intentional. So maybe they are not guided by conscious intention, but they are voluntary, like the way of speaking that I'm using. Of course, I'm not forced, I'm not coerced. But probably neuroscientists will say these are habitual actions, not voluntary action. This is another kind of distinction that I didn't mention, but is usually done in neuroscience. There is a beautiful article by Ray Dolan and Peter Dayan, who are neuroscientists working on this topic specifically, is called Of Goals and Habits, where the distinction is exactly between goal-directed actions, which are what we may call intentional actions in the sense of being actions that are guided by conscious mental states and that have a specific goal, and habitual actions that are all the actions that are voluntary, but they have not a specific goal. I don't have any goal in my mind when I'm doing that. I'm not consciously planning to do something or anything like that. And again, there is some discrepancy at the neural level between and the mechanistic level, the computational level. Basically, the learning model is very different. The way we learn to do this kind of things you were mentioning is completely different from the way we are learning intentionally driven intentional actions. So even on that, we can see a continuum, of course. It's not that we see sharp distinction, but we can make some distinction at the computational, neural level, brain level, etc. Thank you. That's not an easy question, of course. Okay. Yeah, okay. So let's say that for Libet, at least, the way you operationalize this understanding of internal act is an act that is not immediately driven by an externally recognizable cue. So nothing in the environment, like a sensory, visual cue. But that's internal for him. That will count as internal if it's memory. So it must come from something you have inside. So of course, memory will count as an internal action, and which is a bit more contentious, I think, it should not be something that is driven by an obvious discrepancy between the value of the opportunity you have in front of you. So for instance, if I ask you if you want to choose between €1 and €100, and you're free to decide, probably you will go for the €100. For Libet, this will not count as an internally generated action, because even though it is guided by your obvious preference, it is guided by an externally driven preference that I'm putting in front of you, etc. So that's the idea, something that where you cannot recognize a specific cue. I think it's not very satisfying as a definition, of course. It's not something philosophers would be very fond of, is the way it is operationalized here. I would say that even Aristotle has probably some difficulty in explaining exactly what it means, an action that generates from within, and he has the concept of boulesis and all the others, but yeah, probably we are not completely satisfied by that as well. So I think it's an enduring